So in this session we are going to discuss about the CPU scheduling algorithm. Main objective is to discuss about the basic concepts and the scheduling criteria and different type of scheduling algorithms. General multiprogramming is defined as multiple programs that are loaded in the memory for execution. So with this, several processes are kept in memory at one time. Every time a running process has to wait, another process can take over the use of the CPU. So with this, frequently we will be switching the CPU among the process. So we will be having an illusion that n number of programs are executed simultaneously. So with this, we have to keep the CPU in a maximum utilized manner. So in general, the process execution consists of a cycle which consists of two burst times, that is CPU time burst and the IO time burst. So the processes alternate between these two states. Finally, CPU bursts in with the system request to terminate the execution. So this is alternating sequence of CPU and IO burst. Initially, it will be starting with CPU burst. Whenever the wait event or IO happening, so it will be entering into the IO burst segment. Most of the time, the computation part will be done in the CPU burst, and the input-output request or the wait event will be happening with the IO burst time. And finally, it will be end with the CPU burst. Next important software component is a CPU scheduler. So the CPU scheduler selects a particular process in the memory that are ready to execute and allocate the CPU to one of them. There are two categories of CPU scheduling algorithm. One is preemptive and second one is a non-preemptive. So with this process state diagram, you can able to explain the preemptive and non-preemptive scheduling. A process switches from running to waiting state, and a process switches from running to terminated state. So these are coming under the non-preemptive scheduling. And a process switches from running state to ready state, and a process switches from waiting to ready state. Eventually, if it leads to the ready state, then it is said to be a preemptive process. And another important module is a dispatcher module, which gives a control of the CPU to the process which was selected by the short-term scheduler. And this involves the functionalities of context switch and switching to the user mode and jumping to the proper location to restart the program. And the time the dispatcher takes to stop one process and start another is said to be the dispatch latency. Next is the scheduling criteria. So why we need this scheduling criteria? Because of comparing different CPU scheduling algorithms, we require some parameters. So these are the parameters. CPU utilization. So at any point of time, we have to keep the CPU in a maximum utilized manner. Throughput is nothing but the number of processes that are completed per time unit. Response time. So the amount of time it takes to submit a request until the first response is produced. So the time taken is said to be the response time. Waiting time, the amount of time before a process starts after first entering the ready queue. That is, some of the amount of time a process has spent in the ready queue. And the last criteria is turnaround time. That is, amount of time to execute a particular process from the time of submission through the time of completion. So these are the various scheduling criteria for comparing the different CPU scheduling algorithms. So based on this criteria, so how we can able to select the particular algorithm is best for a given scenario. So these are the important things. So we have to keep the maximum CPU utilization and maximum throughput. The turnaround time, waiting time and response time should be in a minimized manner. So next we shall discuss about the single process scheduling algorithm. So there are four algorithms well known: first come first served, shortest job first, priority, and then round robin. So under the FCFS scheduling algorithm, so whatever the process enter into the system first, so it will be allocated the CPU first. So with a simple example we can define the FCFS scheduling algorithm. So we'll be having three processes P1, P2, P3 and the corresponding burst times are 24, 3 and 3. So we'll take the millisecond as a time unit. So we can pictorially represent the schedule allocated by the CPU as is said to be the Gantt chart. So initially the process P1 is entering into the system and it is executed for 24 milliseconds. So 0 to 24 P1 completed. After that the P2 is entering into the CPU for another 3 milliseconds. Then totally it is of 27 milliseconds. And finally the process P3 will be executed by the CPU for other 3 milliseconds. So total burst time is about 24 plus 3 plus 3, it is about 30. So with this Gantt chart we can able to calculate the waiting time for each and every process. So the waiting time for P1, so it is waiting to acquire the CPU's control. So it is not waited any time. So it is 0 millisecond. And P2 is waiting to complete the task of P1. So 24 millisecond the P2 is waiting. And for P3, so put together P1 and P2 completion. So P3 will be waiting for 27 millisecond. So if we take the average, it is about 17 millisecond, and we can able to calculate the turnaround time. Turnaround time we can able to calculate using waiting time plus the burst time. So if you take P1, so P1's waiting time is 0 and P1's burst time is 24. So the turnaround time is 24, and P2 waiting time is 24 plus burst time is 3, so it is about 27. And for P3 waiting time is 27 plus burst time is 3, so it is about 30. So divided by 3 will be getting 27 millisecond as the average turnaround time. So the arrival of the process will have a major impact in this FCFS scheduling. So it will be producing a convoy effect. So convoy effect is nothing but all the other process wait for a long running process to finish using the CPU. So this is, we have taken an example in the case 1. So now suppose the process are arriving in this order P2, P3 and then P1. So P2 and P3 are having the lower burst CPU time and P1 will be having a long running time. So P2, P3, P1 in this order it is arriving. So with that we have produced a Gantt chart and we have calculated the average waiting time and turnaround time. It is about 3 millisecond and 13 millisecond respectively. So in this case the average waiting time is much better than the case 1. So to avoid this convoy effects we have to execute the low burst time process and then the longer time process. So here we can able to utilize as a higher CPU utilization. And finally the FCF scheduling is coming under the category of non-preemptive. So once the CPU has been allocated to a particular process, that process keeps the CPU until it releases it, either by terminating or by requesting the input output. Thank you.